Hi everyone, good day. This is Dr. Von, and for today, we will be discussing all about your carbohydrates. So finally, we are already discussing the different substances or analytes that you are going to test in clinical chemistry. So again, we will be discussing your carbohydrates. So our reference handout for this discussion, marami tayong kinunan na books for this discussion, comes from your Bishop, from your Henrys and your Teats, and also Harrison's Principles of your Internal Medicine 20th edition and your American Diabetes Association Standards of Medical Care in Diabetes 2021. So what would be our learning objective for today? So for today, at the end of this video lecture, the student will be able to, we will go back again in classifying your carbohydrates in their respective groups. So somehow a review of your biochemistry. Next, discuss the metabolism of carbohydrates in the body and the mode of action of hormones in carbohydrate metabolism. Again, not just biochemistry, we will also review your physiology. Then later on, we will differentiate hyperglycemia versus your hypoglycemia. This is where your clinical correlates will come in. Then, we will differentiate the types of your diabetes by clinical symptoms and laboratory findings. And then, identify the different laboratory methods to diagnose your DM. So, this is just an initial laboratory test to diagnose your DM. The laboratory applications for your carbohydrates will be purely discussed naman sa ating laboratory part. Next, identify relate the expected laboratory results and the clinical symptoms. So first, let's go again with the general description of your carbohydrates. So when we say carbohydrates, this is the most abundant organic molecules in nature. As we all know, carbohydrates are the major food source and energy supply for the body and are stored primarily in two most important organ system, your liver and your muscle glycogen. So they are stored primarily as liver and muscle glycogen. So major energy source will be your glucose. Storage form of your energy will be in the form of glycogen. Component of cell membranes, of course, we all know that your carbohydrate is also part of your glycoprotein of your cell membrane. Remember, glyco, that is carbohydrates. And then structural components in plants, bacteria, and other animals, including your insects. So again, it is a compounds containing carbohydrate, containing your carbon, hydrogen, and oxygen, containing your C double bond O and your hydroxide or your OH functional groups. So we have these different structures of your carbohydrates, or these are now the different projection to show the different forms of your carbohydrate. This diagram, this is now your Fisher projection, as it will just show a linear structure. Pag linear structure, that is just basically a Fisher projection. This type, cyclic monosaccharide, basta it shows a cyclic structure that is now your, ano nga tawag dito? If this is Fisher, this is now your Haworth projection. It shows the cyclic structure as viewed from the side, showing the stereochemistry or location of your attached molecules to your monosaccharide ring. And lastly, what do you call this configuration or projection? This is now in chair conformation. It is also possible to have a both type of conformation in which your C1 is tilted upwards in the same direction as your C4, which is less common. So these are the basic structural structures of your carbohydrates or your projection. Again, Fisher pag linear, Haworth pag cyclic, and lastly, now the chair conformation. It looks like now a both conformation. So now let's classify your carbohydrates. I know you already have an idea on how to properly classify your carbohydrates. So in terms of classifying your carbohydrates, it is based on 4 different properties. What are these properties? Number 1, the number of sugar units. So I am referring to ilang sugar molecule ang present for that particular compound. Isang sugar unit lang ba? Dalawang sugar unit, tatlo, apat, or even more than 10. So that's the basic classification of carbohydrates that we know. And secondly, there's another classification, the size of the base carbon chain. And the third one is the location of your CO function group. And lastly, the stereochemistry of the compound. Again, we will review again your biochemistry. I know you don't like your biochemistry, but somehow I'll just simplify our biochemistry review. At least we will have a review again of these important concepts about your carbohydrates. Sige, simplahan lang natin. So the first classification is based on the number of sugar units. Meron tayong tinatawag na monosaccharide. So I'm asking you, ilang sugar unit ang meron sa monosaccharide? Isa, dalawa, tatlo. Of course, kaya naman mono ang tawag kasi there's only one sugar unit. Example, glucose, fructose, and galactose. That's it. We all know about that. How about disaccharide? Your disaccharides, sorry, pumipiyok. Sorry talaga guys. I know tumatawa kayo sa number ng beses na lagi akong pumipiyok sa lecture video ko. Hindi ko talaga alam. Hindi ko makakontrol kung pumipiyok talaga ako. Yung disaccharides, meron tayong tatlo. Just remember MLS. MLS is a disaccharide. Your maltose, lactose, and your sucrose. We all know since it's a disaccharide, kaya ilang sugar unit na meron sa disaccharides? Of course, we have 2. It is a composition or a combination of either your glucose, fructose, and your galactose. Again, remember your disaccharide, MLS. So, again, let's review. Anong composition ng ating sucrose? So, your sucrose is basically composed of glucose and your fructose, while your maltose is a combination of your one glucose molecule and another glucose unit. So that's the composition of your maltose. And lastly, for your lactose, it is basically your glucose and galactose. So this is basically a review lang talaga, no? And again, what joins this 2-unit molecule? Anong nagdudugtong? What do you call that bond? Of course, this is now your glycosidic bond. Again, in chemistry, your glycosidic bond or your glycosidic linkage is a type of your covalent bond that joins a carbohydrate molecule to another group, which may or may not be another carbohydrate. Pwede namang, it's not really necessary na carbohydrate talagang dalawa, but as long as we all know that what joins the two molecules of your carbohydrate, it's really your glycosidic bond. So each sugar molecule is held together by your glycosidic bond. So again, number of unit sugar molecule. Number 3, we have your oligosaccharide. Chaining of 2 or more 10 sugar units. So pag isa, that's monosaccharide. Pag dalawa, that's disaccharide. Pag 2 or 10 sugar units, that is oligosaccharide. Therefore, your disaccharide is basically an oligosaccharide. Please do not confuse ha. Therefore, your disaccharide belongs to oligosaccharides because your oligosaccharides is a chaining of 2 or 10 sugar units. And lastly, we have your polysaccharides. So there are more than 10 units of your sugar molecule. Sample of that, pinaka-common, alam natin, your starch and your glycogen. Again, we're done with the first classification, the number of sugar units. Meron tayong monosaccharide, oligosaccharide, and your polysaccharide. Sa oligosaccharide, meron pa nga tayong disaccharide, trisaccharide, and tetrasaccharide. Pero ang pinaka-common lang kasi na alam natin that is essential in the human body are your disaccharide. Sige, another classification that we need to identify is number 2, the size of the base carbon chain. So ito yung tinatawag natin, the number of carbon atoms, the size of the base carbon chain. Pag sinabi nating triosis, ilang carbon atom meron? Of course, from the name itself, triosis, meaning may tatlo. Pag sinabi nating tetrosis, merong 4, pentosis 5, hexosis 6, heptosis 7. Of course, I will have more example of that later on. So again ha, next, again, ito yung example na sinasabi natin, the size of the base carbon chain. Monosaccharides. So merong mga monosaccharides that are hexoses. There are also monosaccharides that are pentoses. Example of monosaccharides that are hexoses, glucose, fructose, galactose, and your mannose. Example of your monosaccharides that are pentoses, or there are 5 base carbon chain. We have your ribose, ribulose, and your cellulose. Next, the location of your CO functional group. So your CO, your carbonyl functional group, now dito na lumalabas whether that is an aldose versus a ketose. Always remember that the two forms of carbohydrates are aldoses and ketoses. Just remember that. It could either be an aldose or it could either be a ketose. Pag sinabi nating aldose, the functional group is an aldehyde. Kaya nga tinawag siyang aldose kasi the functional group is an aldehyde. So this is the basic structure of your aldehyde. So C double bond O, merong R group and another hydrogen. Your R group dito, this refers to any group in which your carbon or hydrogen is attached to the rest of the molecule. That's your R group. So example of this one, we have your glucose, galactose, and your mannose. And also the most important differentiating factor for aldose is that your carbonyl carbon is at the end. So this is the carbonyl atom, your C double bond O, that is found at the end. Remember that we will compare that to your ketosis. For your ketose, ito na yung sa ketose natin. Ketose, the functional group is a ketone. Kaya tinawag siyang ketose because the functional group is a ketone. The carbonyl carbon is at any other position. Therefore, or meaning nasa middle. It's not at the end, but it's either in any position as long as in the middle. So example of that is your fructose. Again, let's differentiate ha. Aldose, when we say aldose, the functional group is an aldehyde. When we say ketose, the functional group is a ketone. And your carbonyl carbon, once pag sinabi natin carbonyl carbon, referring to the C double bond O, pag aldose, at the end. Pag ketose, at any other position. Sige, we will have a better picture on that. Or example, this one. Tingnan natin, these are your aldoses, your glucose. Aldoses, you have your glucose. When we say aldoses, where can you find your C double bond O? Aldoses, for example, remember, glucose is an aldose. Saan natin matatagpuan ang carbonyl group ng ating glucose? Since glucose is an aldose, therefore the carbonyl group is located at the end. So C double bond O. So you see na the difference? The carbonyl group is now at the end. Very good. And what is the ano nga ang ating functional group? The functional group of your aldehyde is your aldoses is an aldehyde, as also seen in this diagram. So this is also an aldehyde. So nakikita nyo na, no? That's an aldehyde. Next, how about your ketosis? Your ketosis now, or the functional group of your ketosis is this one. So saan natin matatagpuan ang ating carbonyl group for your ketones? The carbonyl group of your ketones or your C double bond O is located not at the terminal as long as in any position. In any position except at the terminal or the end part. So as what you can see, this is not the terminal part. Nakikita natin yung C double bond O, then most probably this is now a ketose. An example of your ketose is a fructose. I hope you appreciated the difference now, ha? You find the functional group and you find the presence of your carbonyl function or carbonyl group. Ang pinaka-importante yung carbonyl group or carbonyl function natin, just look at the C double bond. Kung saan yung C double bond O, most probably it will tell you whether it is an aldose or a ketose. Again, pag aldose, nasa tip ng ating structure. Pag ketosis, nasa gitna. Any other position, basta nasa gitna except lang sa terminal. Wala sa terminal. Kasi pag terminal, that's automatically your aldose. I hope now you can classify whether it is an aldose or a ketose. We're already done with the 3 most important classification. Now let's proceed with the last classification of your carbohydrates. This is now the stereochemistry of the compound. when we say stereochemistry of the compound, it's actually a study of the spatial arrangement of atoms. So we are talking about the 3D or the 4D configuration of your carbohydrate. So how the molecules are being arranged in a 3D or 4D configuration. So tingnan natin. The first terminology that I want you to remember is the word isomer. When I say isomer, these are compounds that have same chemical formula. As long as they have a same chemical formula, that is isomer. So example, glucose, fructose, galactose, and mannose are all isomers of one another because they have the same formula, which is C6H12, which is O6. Again, pag sinabing isomer, same chemical formula. I hope that's clear. Very basic. Next, how about epimer? Pag sinabi nating epimer, these are isomers that differ in configuration around only one specific carbon atom except the carbonyl carbon. Again, so therefore we can say that all isomers are epimers. Kasi it's technically epimers are isomers that differ in configuration. Example, glucose and galactose differ only in the possession of your OH in C4. Glucose and mannose differ only in the possession of OH in your C2, as long as they just differ in configuration around only one specific carbon atom. Sige, we have a better diagram to that. Sige, ito, isomers that differs in configuration around one specific carbon. Example natin, glucose and galactose. Glucose, galactose differ only in the possession of OH in C4. So, tingnan natin, galactose natin sa C4, syempre, nag-differ lang sila sa possession ng OH sa C4. So, therefore, glucose and galactose, they are epimer at C4. That's how you classify that. Very good. Next, your glucose is also epimers with your mannose. Paano natin masabi? Glucose and mannose. Because they differ only in the position of, saan sila nag-differ dito? At what carbon, at what number of your carbon? 1, 2, 3, or 4. Of course, naka-highlight na. Nakita lang natin, they just differ in your carbon number 2. Kasi parehas sila sa 3, 4, 5, 6. They just differ in your carbon number 2. So therefore, your glucose and mannose epimer at C2. Very good. We have also another terminology that I want you to remember, your enantiomer. So basically, enantiomer, optical isomers or stereoisomers. So pairs of structures that are mirror images of each other. So basically, mirror image, that's it. So the enantiomer are designated as D sugar, that is your dextrorotatory, and an L sugar, which is your levorotatory. So D sugars are more common. So ito yung sinasabi natin, yung enantiomer, mirror image. So what you can see, your D-glucose and L-glucose, they are just mirror image. So example, your L-glyceraldehyde and your D-glyceraldehyde, your L-glucose and your D-glucose. These are just a mirror image. Another terminology, pag sinabi nating anomers, ano yan? In aqueous solution, your monosaccharide with 5 or more carbon atom in the backbone occurs predominantly as cyclic or ring structure. Again, once in aqueous solution, yung mga monosaccharide natin is nagiging cyclic ring structure. So let's take a look at this one. For example, your furanose, this is actually a monosaccharide structure with a 5-membered ring. Pag sinabi nating pyranose, these are your monosaccharide structure with a 6-membered ring. So, the rotation around the carbonyl carbon produces now your anomer. So, basically speaking, pag sinabi nating anomer, it's the rotation around the carbonyl carbon produces the anomer, which is labeled as alpha or beta anomer. So, unlike your epimers, your anomers can undergo interconversion. Pwede siyang from alpha to beta or beta to alpha kasi vice versa without energy expenditure or need for enzymes in a process called mutarotation. So I have a better picture here. This one. Again, these are your pyranose. Remember, when we say pyranose, these are monosaccharide structure with a 6-membered ring. Count natin. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So these are your pyranose. And rotation, remember, pag sinabi ng anomers, rotation around the carbonyl carbon produces your anomere. So remember, hanapin natin yung C double bond O. Of course, nandito yung oxygen. So therefore, saan yung merong rotation around your carbonyl, that's gonna be your anomere. So in this part, this gonna be the anomere part. And you just label that whether it is an alpha and beta. Again, paano natin malalaman ang anomere? You look at for the carbonyl carbon. Of course, we all know that the C double bond O, nandito yan kasi nandito yung oxygen natin. So therefore, rotation around, saan dito ang may rotation around is here. So therefore, as long as you label now that as alpha or beta, pag nasa baba ang OH, you label that as an alpha. Pag nasa ibabaw ang OH, you label that as beta. As simple as that. That's it. Just locate for the oxygen, your carbonyl group, and then you look at for the OH. Kung saan nakalagay ang OH, that's basically now your clue whether that is an alpha anomere or beta anomere. Pag nasa baba, that is gonna be your alpha. Pag nasa ibabaw, that's gonna be your beta. Ayos pa ba tayo? Sige, let's review again. Sige, don't you worry. I-review natin para hindi natin makalimutan agad-agad. Let's review. When I say isomer, they have same chemical formula. As long as they have same chemical formula, I don't care about the structure. As long as same chemical formula, they're gonna be ang tawag sa kanila ay isomers. Epimers. Ano ang epimers? Kapag same na same ang itsura pero naiiba lang ang position ng OH sa isang carbon, that is now your epimers. Again, kapag same na same ang itsura pero naiiba lang ang position ng OH ng isang carbon, that is your epimers. Enantiomer, pag sinabing enantiomer, mirror images, na-flip ang position ng OH. That's basically, na-flip lang ang position ng OH. May mirror lang, kumbaga, it's just a mirror image. That's your enantiomer. And lastly, your anomers, na iba ang position ng OH sa anomeric na carbon. Pag alpha, pag nasa baba yung OH, beta, pag nasa taas yung OH ng anomeric. Ang mnemonic ko dyan, para hindi ko siya makalimutan, beta-as, A-baba. Beta-as, A-baba. Okay, walang silbi. Bahala kayo dyan. Actually, that's my mnemonics during my board exam review sa biochemistry. So, beta-as, A-baba. Just remember that, okay? So I hope you were able to classify these different terminologies sa ating stereochemistry, the isomer, epimer, enantiomer, and anomers. If you still have any clarification on this part, please do not hesitate to PM me anytime, okay? Now let's talk about the metabolism of your carbohydrates. So tapos na tayo sa review ng biochemistry. Sa wakas, tapos na. Now, let's talk about your metabolism of carbohydrates. Dito naman papasok ang review natin ng physiology. Of course, di ba? Ang dami ng subject na natin na-incorporate natin. After biochemistry, we will now proceed with the review of your physiology. How is carbohydrates being metabolized inside our body? So, the question is, paano saan tayo nakakuha ng ating carbohydrates? Of course, it comes from the food source. Rich in carbohydrates, of course, our rice, our breads, fruits, even our chocolates. So anything that has carbohydrates, any food. So what will happen is that kakain tayo, of course, so your salivary amylase will be stimulated and it begins your digestion in the mouth. So ito yung tinatawag natin na initial digestion of your carbohydrates. And then, after that, papasok sa ating stomach. What will happen? Your salivary amylase is denatured by your stomach acid. And then, your food will now go to your initial digested food will now go to your small intestine. And that will stimulate the release of your pancreatic amylase. So, aside from salivary amylase, meron din tayong pancreatic amylase wherein it will continues the digestion in your small intestine. And also after that, the enzymes at their microvilli will break down the carbohydrates now to become monosaccharide, because what is being absorbed by your small intestine is not the disaccharide, oligosaccharide, or polysaccharide. It must be digested to become monosaccharide for it to be absorbed by the body. Resistant starches and fibers are digested and fermented in the large intestine and the colon. Kasi nga, ano lang mapapasok or ma-absorb ng ating katawan is basically your monosaccharide. Remember, again, your carbohydrate is a major food source and energy supply of our body. So again, absorption. Paano nangyayari? Tapos na tayo sa digestion. So ang next step na sa ating physiology is basically absorption of your monosaccharide. Na-digest na natin siya into monosaccharides because remember, only monosaccharides are absorbed. So in the luminal side, your SGLT1, these are different transporters. Baka nako-confuse kayo. These are transporters. Pag sinabi natin transporter, that refers to the different transporter that will transfer your monosaccharide going to your system or to be absorbed in the body. So, anong ginagamit niyang transporter para makapasok sa ating katawan? Your SGLT1, your secondary active transport for glucose and galactose. Your GLUT5 through your facilitated diffusion for fructose, and at the basolateral side, your GLUT2 using also your facilitated diffusion, all types of your monosaccharide. Sige lang, I'll have a better picture on that para mas lalong maintindihan. This one, sa luminal side, of course, this is your small intestine. At this part, lumen ng ating small intestine. Paano siya makakapasok sa ating epithelial cells of the small intestine bago makapasok sa blood? Of course, hindi siya pwedeng from lumen, agad-agad blood. Of course, it has to enter the epithelial cell of your small intestine. Your small intestine. Again, remember the two important transporter, your SGLT1 and your SGLT1 and your GLUT5. Kasi your SGLT1 will transfer your glucose and your galactose, while your GLUT5 will transfer your fructose towards or inside your epithelial cells. Please remember that. SGLT1, glucose, and galactose. GLUT5 is fructose. Doc, bakit yan may sodium? Remember, this is your sodium-glucose transporter. So, dalawa ang na-transport niya. Not just your glucose, but also your sodium. Kaya tinatawag siya niya sodium-glucose transporter 1. So, glucose and galactose for SGLT. For GLUT5, only fructose. So, therefore, tingnan natin, your glucose, galactose, and fructose, these are all monosaccharide. Now, what will transfer the different monosaccharide inside your small intestine will be your GLUT2. Remember, your GLUT2 will transfer all types of monosaccharide, including your glucose, galactose, and fructose. So therefore, lalabas na siya, makakapasok na siya sa ating blood. Again, with fillings. Only your monosaccharide, your glucose, galactose, and fructose can be absorbed in your small intestine. We cannot absorb your disaccharide or your polysaccharide. Your SGLT1 is used to absorb your glucose and galactose from the lumen to your intestinal cell. Your GLUT5 for fructose from lumen up to your intestinal cell, and your GLUT2 is used to absorb glucose, galactose, and fructose from the intestinal cell to the blood. Kaya, grabe na yung paulit-ulit na yun ha. Dapat matandaan nyo na yun. Sige na, please. Okay, another diagram. Nakikita nyo, this is the lumen. Kasi na, ito yung microvilli natin. These are the lumen of your small intestine. Paano sila makakapasok? Using your different transporter, your SGLT1 and your GLUT5 for fructose, your SGLT1 for glucose and your galactose para makapasok sa ating epithelial cell. Then, lalabas patungo sa ating dugo using now your glucose. Again, with fillings, only monosaccharide, glucose, galactose, and fructose can be absorbed in the small intestine. We cannot absorb disaccharide or your polysaccharide. Your SGLT1 is used to absorb your glucose and your galactose from the lumen to the intestinal cell, and your GLUT5 for fructose from the lumen up to your intestinal cell. And lastly, for GLUT2, it will use to absorb your glucose, galactose, and fructose from the intestinal cell to the blood. I hope memorize na. Memorize na talaga yan. Ako rin, memorize ka na po ulit-ulit. Okay, we're done with the absorption. So, tapos na tayo. Na-digest na natin. May source na tayo ng pagkain. Dinigest na natin. Nakapasok na. Ang next question is, what is now the different glucose metabolism? I hope na-appreciate nyo no, na-imagine nyo na the all steps na, i-review natin lahat ng steps na ginagawa from being a complex carbohydrate to becoming a monosaccharide. Now, let's proceed. Na-absorb na natin, na-digest na natin, na-absorb. Then now, the question is, pag nasa dugo na, anong mangyayari sa ating glucose? So, your glucose will undergo different pathways. Excuse me. So, these are the different pathways. Again, parang biochem naman to. Excuse me, sorry talaga. Sorry, excuse me. Your glucose pathway, meron tayong tinatawag na glycolysis. We have gluconeogenesis, glycogenolysis, glycogenesis, lipogenesis, and lipolysis. I want you to be familiar with two important terminologies, well-fed state and your fasting state. Pag sinabi nating well-fed state, of course, kakakain lang natin. So therefore, what is the expected sugar level sa ating katawan? Increase or decrease? Kakakain lang natin. Of course, mataas because we have a food source of your or glucose source from your food na source. Next, pag sinabi nating fasting state, what do you mean by that? Fasting state, of course, mababa ang sugar sa ating katawan. So please remember these two terminologies para makorelate natin sa different pathways. Well-fed state and your fasting state. When we say glycolysis, it is the metabolism of your glucose molecule to pyruvate or lactate for production of energy. So therefore, gagamitin mo yung glucose natin for the production of energy. The question is glycolysis a well-fed state or a fasting state? Sige, isipin natin, well-fed state or fasting state? Remember, you need glucose molecule. Of course, magkakaroon kayo ba ng glycolysis kung wala kang glucose sa katawan? Of course, hindi. So therefore, we can say that generally speaking, your glycolysis in us is in well-fed state. Remember your glycolysis is generally in a well-fed state. So therefore, pag maraming glucose sa katawan, it will be metabolized now for energy production. Remember that. Okay, glycolysis, we're done. Now let's proceed with your gluconeogenesis. When we say gluconeogenesis, it's the formation of your glucose from a non-carbohydrate source. It could be from your lactate, from your glycerol, or commonly from your amino acid. So therefore, pag sinabi natin gluconeogenesis, formation of glucose from a non-carbohydrate. Ang gluco talaga yung neo, pag neo, nan. From a non-carbohydrate source. So therefore, is this a well-fed state or a fasting state? Gumagawa ka ng glucose from a non-carbohydrate source. Is it a well-fed state or fasting state? Of course, this is a fasting state. Kasi nga, bakit ka na naman gagawa ng glucose kung well-fed state ka? Remember, in a well-fed state, marami kang glucose. So bakit ka gagawa pa ng glucose? Of course, hindi na. So therefore, your gluconeogenesis will only happen during a fasting state. Pag wala ka ng source ng glucose, of course, it will get another source of glucose from the different sources, either amino acid, glycerol, or your lactate. Again, gluconeogenesis from a formation of glucose from a non-carbohydrate source. Therefore, you form glucose because kulang ang ating glucose. Therefore, this is during your fasting state. Very good. Next, glycogenolysis. From the term itself, lysis and glycogen. You break down, this is basically, you lyse or you break your glycogen to glucose for energy. Therefore, nagbe-break ka ng glycogen to form glucose. Is this a well-fed state or fasting state? Guys, you think you try to answer. Even this is only a lecture video recorded lang. I mean, I'm not hearing your answers. Please try to answer yourself. At least you can see na if tama bang pagkaintindi mo or hindi. Again, glycogenolysis. Well-fed state or fasting state? Of course, this happens during fasting state because nagbe-break ka ng glycogen kasi nga wala ka ng glucose. So kumukuha ka ng glucose from your glycogen. So basically, this happens during a fasting state, not well-fed state. Bakit hindi sa well-fed state? Bakit ka magbe-breakdown ng glycogen to form glucose kung marami ka pa namang source from a well-fed state? Of course, this happens during a fasting state. And lastly, sorry. Naman. Sorry talaga. Next, your glycogenesis. Your glycogenesis, conversion of glucose to glycogen for storage. Glycogenesis. So, genesis, formation of your glycogen. So, bakit ka magpo-form ng glycogen? Bakit mo? Remember, your glycogen is a storage form. Does this happen during a well-fed state or fasting state? Remember, glycogenesis. Of course, this happens during a well-fed state. Kasi nga, marami kang glucose. So, therefore, i-convert mo ang glucose into glycogen for storage. That is glycogenesis. How about lipogenesis? Lipogenesis, conversion of carbohydrates to fatty acids. Of course, this is also during a well-fed state kasi marami kang source ng carbohydrates that you will convert it to fatty acids. How about lipolysis? Lipolysis, basically, this is a decomposition of your fat. So again, these are the different pathways of your glucose. Could either be your glycolysis, gluconeo, glycogenolysis, glycogenesis, lipogenesis, and lipolysis. I hope you understand the concept between a well-fed state and a fasting state, because whether a person is on a well-fed state or a fasting state, dyan din magdedepende on what pathway your glucose will undergo. Again, this is just a review of our discussion of the catabolism of your carbohydrates. Again, from a polysaccharide, we converted that, digested that to your glucose and your fructose and your galactose. And then when it goes inside the body, it will undergo different processes. One example is glycolysis. Your glycolysis is also important in the formation of your energy. But however, in glycolysis, energy is not sufficient. So therefore, the end product here is pyruvate. And your pyruvate needs to enter your mitochondria for different processes. So pyruvate needs to enter mitochondria. That's why i-convert siya into acetyl-CoA. And this is the time your acetyl-CoA will undergo citric acid cycle and then further undergo your electron transport and your oxidative phosphorylation so that more energy is being generated. Kasi nga, yung glycolysis na energy, hindi masyadong marami. But it will undergo your citric acid and your ETS and your oxidative phosphorylation. It will create more energy. So, we already discussed this one. Very good. Now, let's talk about the different hormone regulation. So, Doc, what are the different hormones that control the level of your glucose? Hindi lang pwedeng si glucose, papasok ako sa cell, gusto ko lang pumasok doon. Hindi pwedeng lalabas ako, mapaparami ako. Of course, it is under a hormonal regulation. But please remember these two important terminologies. Your brief fast, glucose is supplied to the ECF from your liver. But fasting period longer than 1 day, glucose is synthesized from a non-carbohydrate sources. Again, during a brief fast, glucose is supplied to the ECF from the liver through your glycogenolysis. When the fasting is more than 1 day, glucose is synthesized from other sources through your, ano nga yung formation of glucose from a non-carbohydrate? Your gluconeogenesis. Very good. This is now your gluconeogenesis. Control of your blood glucose and is under two major hormones. So, ano kayang dalawang hormone? Two major hormone that will control your blood glucose level. It is your insulin and your glucagon. Very good. These are both produced by your pancreas and their action will oppose each other. Malalaman natin yan later on. Again, remember your insulin and your glucagon. Again, these are the different hormone regulation. Insulin, glucagon, epinephrine, cortisol, growth hormone, your ACTH, your thyroxine, your somatostatin, and your incretin. So later on, we will know ano kayang effect ng mga different hormones na ito. Does it increase your glucose in the blood or decrease your level of glucose in the blood? That's gonna be the question. Malalaman natin yan in a while. So, but first, in a normal physiologic aspect, what is the homeostasis of your glucose? How does your glucose is being balanced inside the body? So, ganito ang nangyayari sa ating katawan. Homeostasis of your blood glucose level. If there is a high level of your glucose, Doc Von, bakit nagkakaroon ng mataas na sugar sa ating blood? The stimulus, rising blood glucose level, pwedeng after eating a carbohydrate-rich meal. Of course, kakakain mo lang. Therefore, tumataas ang blood glucose level. So, what will happen is that an increase in your blood glucose level, your beta cells of your pancreas is stimulated to release your insulin in the blood. So, therefore, again, pag mataas ang sugar ng ating katawan, what is stimulated is your beta cells of your pancreas and it will release insulin. The question is, what will be the action of your insulin? Your insulin, it will cause body cells take up more glucose. Of course, papasok ang glucose towards our cell. And what else? Your liver takes up glucose and stores it as a glycogen. So again, ang gagawin ni insulin, pwedeng ipapasok niya patungo sa cell or pwede niyang isostore as glycogen in your liver. And what will happen or what will be the end effect of your insulin? Therefore, your blood glucose level declines to a set point and the stimulus of insulin release diminishes. Of course, pag na-normalize na yung sugar level sa ating katawan, of course, mawawala na rin yung stimulus ng ating insulin. So that is the basic glucose homeostasis. How about pag mababa naman ang ating glucose? Anong mangyayari sa ating katawan? Doc Von, anong reason bakit mababa ang blood glucose ng level ng ating katawan? Of course, kasi aral tayo ng aral, hindi na tayo kumakain. What will happen? There is, ang stimulus natin, removal of excess glucose from the blood or low blood glucose level after skipping a meal because a medtech student is studying, hindi na kumakain. Pero I doubt if you're not eating, mas maraming kain kaysa aral sa pagkakaalam ko. So your low blood glucose level after skipping a meal, anong mangyayari? Mababa ang glucose level and what is being stimulated? Hindi na ang beta cell but your alpha cells of your pancreas will be released in the blood. The question is, what will be the action of your glucagon? Your glucagon, liver breaks down your glycogen and releases glucose to the blood. Again, because remember, nagiging storage form yung glucose natin sa liver and ang action ng glucagon, i-break niya yung glycogen and release glucose in the blood. And what will happen? There will now be blood glucose level rises. Tataas na yung blood glucose level kasi meron tayong source ng glycogen ng glucose from our glycogen. And again, mawawala na ang effect ng ating glucagon pag naabot na natin yung normal na level. And babalik siya sa homeostatic or your blood glucose level becomes normal. So again, the most important two hormones na diniscuss natin dito is your insulin and your glucagon. Again, their effect is opposing. Pag mataas ang sugar level, insulin ang mag-e-effect para gusto nating mawala yung sugar. Pag mababa ang sugar level, glucagon ang mari-release because gusto nating tataas ang sugar level. I hope that is clear. So right now, isa-isahin na natin itong mga different hormones na ito. Again, when we say insulin, beta cells this is produced by your beta cells of the islets of Langerhans. So remember that ha? Ito man talaga pinaka-importante yun, insulin and your glucagon. Kung meron tayong dapat tatandaan sa mga action and function, it's really your insulin and your glucagon. So anong stimulus ng ating insulin? Kailan lang masistimulate ang ating insulin? Pag merong hyperglycemia or increase in your blood glucose level. So what are the actions of your insulin? Promotes glucose cellular entry. Of course, papasok ang glucose patungo sa ating cells para bumaba ang level ng glucose, ang blood glucose natin. And also, muscles and adipose tissues. And also, increases glycogenesis, formation of your glycogen, lipogenesis, formation of your fats, and lysis. This is the metabolism of your glucose as a source of your energy, and it will inhibit your glycogenolysis. Of course, we don't want more carbohydrates coming from your glycogen. So therefore, ayaw nating ma-break ang ating glycogen, kasi kung ma-break down ang ating glycogen, more glucose ang mangyayari. So therefore, insulin must your insulin must inhibit glycogenolysis. Again, no, kaya nga, importante, malaman nyo talaga yung mga action ng glycogenolysis, yung mga different pathway na di-discuss natin para mas madaling maintindihan. Again, that's very basic. Again, the only hormone that lowers your blood glucose, this is your hypoglycemic agent, this is your insulin. Majority of the different hormones na ating i-discuss will cause an increase of your glucose, except really your insulin. So, Doc Von, paano ba nagagawa ang ating insulin? So, I know that your insulin, this will be discussed when you reach your endocrine, your clinical chemistry 2. I like clinical chemistry 2 versus CC1. To be honest, I prefer CC2 than CC1 because in the CC2, doon natin madidiscuss yung mga endocrinology, yung mga enzymology, electrolytes. Mas maganda ang mga discussion kasi it's more of a visual lang kasi siya. Unlike dito sa ClinChem 1, marami tayong mga lab math, marami tayong mga napaka-technicals like mga QC and QA. I don't know, personally, I prefer CC2. So sa CC2, madidiscuss yung endocrine, specifically your insulin. But right now, I just want to emphasize how insulin is being produced. Again, your insulin is produced in your what cells of your pancreas? It's in your beta cells. It is initially synthesized as a precursor polypeptide, tinatawag natin na pre-proinsulin. Subsequent proteolytic processing removes the amino terminal signal peptide giving rise to your proinsulin. Napaka-technical. Gusto ko lang malaman, from pre-proinsulin, magiging proinsulin. That's it. And then, after several processes, ang proinsulin magiging insulin. But again, hindi lang insulin ang nare-release. It will also release your C-peptide. Remember that, ha? Your C-peptide and insulin are both released. The mature insulin and C-peptide are stored together and co-secreted by your secretory granules in your beta cells. Ito. Again, your insulin and your C-peptide are stored together and co-secreted from your secretory granules in your beta cells. Because C-peptide is cleared more slowly than insulin, it is now a useful marker of your insulin secretion. That's why nire-request namin yung C-peptide. Again, ha, always remember that dalawa ang nare-release, not just your insulin but also your C-peptide. And mas slowly na metabolize or nakiklear ang ating C-peptide. So therefore, this will now be a useful marker of insulin secretion rather than using insulin itself. Kasi nga, mas mabilis na ma-metabolize ang insulin versus your C-peptide. And using your C-peptide, it allows now a discrimination of your endogenous and exogenous sources of your insulin in the evaluation of your hypoglycemia. Very good. Again, remember, our insulin is produced in pancreas. So, isa-segue lang natin to. So, remember, histology nyo, ha? Meron tayong exocrine. It could be an exocrine or an endocrine gland. So, exocrine gland, enzymes such as your amylase and lipase is being produced. And an endocrine, 4 hormone from your different cells in the islets of longer hands. Alpha cells from your glucagon will be produced. Beta cells, insulin. Delta cells, somatostatin. And your PP or your F cells produces now your pancreatic polypeptide. Please remember this important na mga cells and their products. But I know you're already familiar with this one with Dr. Ian sa inyong histology. So alam ko, memorize na yan eh. Now, let's proceed with that. So, Doc Von, ano bang trabaho ng ating insulin? So, this is the basic mechanism of our insulin. Of course, your insulin will attach to your insulin receptor. Nakikita nyo, this is the insulin. Your insulin natin, it will attach to your insulin receptor. Napapansin nyo dito yung glucose channel is serado pag wala tong insulin. So therefore, once your insulin is being attached, insulin on receptor, it will now open the glucose channel. Tingnan nyo, biglang nagbukas yung glucose channel. So what will happen is that papasok yung ating glucose, glucose enters cell through a glucose channel. So that is the basic function of your insulin. Without this insulin, there will be the glucose channel will be closed. Okay, tapos na tayo sa insulin. We will now proceed with our glucagon. Saan nga napuproduce ang ating glucagon? It's in the alpha cells of your islets of your Langerhans. So, stimulus natin during stress or yung fasting states. Of course, fasting states or during stress, bumababa ang glucose level ng ating katawan. So, therefore, we need more glucose. So, therefore, your glucagon action enhances your glycogenolysis and your gluconeogenesis. Kasi glycogenolysis, it will cause breakdown of your glycogen, forming now your glucose. Gluconeogenesis, formation of glucose from a non-carbohydrate source. Therefore, the end product is increased blood glucose level. That's a basic discussion on that. Very good. Next, epinephrine. So, epinephrine, alam natin yung epinephrine. This is your fight or flight hormone. So, this is produced by your adrenal medulla. So, stimulus released during stress. Your action, it will cause increased blood glucose level. So, therefore, it will inhibit your insulin. So, parang ini-oppose niya din yung action ng insulin. So, it will also increase your glycogenolysis and it will promote lipolysis. So, parang similar effect lang sila ni glucagon. But remember ha, epinephrine, tatandaan nila, di ba, fight or flight attendance. Kung di ba, kung makipag-away ka, kakailangan mo ba ng sugar? Of course, para makipag-away ka, kailangan mo ng energy. So therefore, iisipin natin, dapat mas mataas ang blood glucose level. So remember that, epinephrine. Again, saan nga napuproduce ang ating epinephrine? It's in your adrenal medulla. So this is your stress hormone. Pag nasa-stress tayo, kailangan ng pagkain, kailangan ng more sugar. So this is your epinephrine and norepinephrine. And again, sa ating adrenal cortex, ano yung tatlong zona? Zona glomerulosa, zona fasciculata, and your zona reticularis. Identify natin yung mga important hormones that being released. Zona glomerulosa, your mineralocorticoids, your aldosterone. Zona fasciculata, your glucocorticoids, your different cortisol, and your androgens for your zona reticularis, your DH, your dihydroepiandrosterone. Very good. So just a review. Remember, cortisol, it will also affect your glucose level. Remember, just to remember the location, ha? Zona fasciculata, glucocorticoids. Again, hormone regulation. Another one, cortisol. Okay, kaka-discuss lang natin a while ago. Again, napuproduce siya sa ating adrenal cortex, sa ating zona fasciculata. Action niya, of course, similar pa rin. Upon the stimulation of your ACTH, it will cause blood glucose level. It will decrease entry of your glucose into the cell and increasing gluconeogenesis, liver glycogenolysis, and your lipolysis. Of course, di ba nagme-make sense? Nagme-make sense yung glucagon, yung epinephrine, and your cortisol. No need to memorize. As long as you know the effect of glucagon, it will now be similar, somehow similar to your cortisol and your epinephrine. Very good. Growth hormone, same pa rin. Increase blood glucose level produced in your anterior pituitary gland. Decrease entry of glucose into the cells and increase your glycolysis. Your ACTH, of course, from anterior pituitary gland, ang stimulus natin pag mababa ang cortisol level. Kanina, di ba, ang cortisol natin umaangat siya because upon the stimulation of your ACTH coming from your anterior pituitary gland. Same pa rin, stimulate cortisol, release, thus increase your plasma glucose, increase glycogenolysis, and your gluconeogenesis. Same, increase blood glucose level. How about your thyroxine, doc? Your thyroxine, this is produced by your thyroid gland in your follicular cells. Stimulus natin upon the release of your thyroid stimulating hormone. Kaya siya tinawag na thyroid stimulating hormone because it will stimulate your thyroid gland to produce now your thyroid hormone. Example of that is your thyroxine or your T4. So action of that, increase glycogenolysis, increase gluconeogenesis, increase intestinal absorption of your glucose. So basically, the end effect is also increase glucose. Right now, ano pa bang hormone na alam natin na nagpapababa ng ating glucose level? Isa pa lang, di ba? It's still your insulin, and majority of your hormone increases your sugar level, blood sugar level. Next, we have your somatostatin. Dito na, your somatostatin produced by your delta cells of your Langerhans of the pancreas and GI cells of the D cells of your duodenum. So the action is inhibitory hormone. Again ha, when you hear the word somatostatin, it is an inhibitory hormone, meaning it will inhibit your insulin, your glucagon, your growth hormone, and other endocrine hormone. So therefore, hindi lang insulin ang ini-inhibit niya, ini-inhibit niya rin ang glucagon. So nga, binabasa ko yung somatostatin as somatostapin. Somatostapin. Kasi nga, somatostatin is generally inhibitory. It will inhibit a lot of hormone. Wala siyang action that will stimulate. Basically, ang action niya talaga is to inhibit. Inhibitory hormone talaga to siya. So, once you encounter the word somatostatin, you know that it is an inhibitory hormone. Because, inhibit niya majority of the different hormones, even your gut hormones or GI hormones. Next, we have your incretins. So, these are gut hormones secreted by your enteroendocrine cells minutes after eating. So, example natin, your GIP and your GLP-1, your glucose-dependent insulinotropic peptide, glucagon-like peptide 1. So, again ha, name niya pa lang, insulinotropic. So, therefore, ang action niya is similar to your insulin. So, your incretins, your GLP and GIP, anong ginagawa nila? It will stimulate the insulin release, inhibit glucagon release. So therefore, incretins will cause the lowering of your blood glucose level. So in short, dalawa pa lang alam natin ng hormones that will cause now a lowering of your blood glucose. This is your insulin and your incretin. Example of your incretin, glucose-dependent insulinotropic peptide. But then again, may pangalan na glucagon. Wag malito ha, wag malito. Tinawag siyang glucagon-like peptide, but the action is not similar to glucagon. Remember that glucagon-like peptide is an incretin, therefore, it will cause lowering of your blood glucose. Napaka-misnomer na yun, pangalan niya glucagon, pero tinawag na sana insulin-like peptide, no? Para hindi confusing. Ano ba itong mga scientists na to? Bakit nila iniiba-iba? Siguro because the peptide itself is similar to glucagon, but the action is really different. Again, anong alam natin na dalawang hormone that will cause a decrease of your blood glucose level? It is now your insulin and your glucagon. Your insulin and your glucagon, your insulin and your incretin will cause lowering of your blood glucose. The rest of the hormones that we discussed a while ago will cause an increase of your blood glucose level. Again, we will now proceed with your clinical correlates.